Hey guys, this is Dan with Pacific Tech Center. Today we are going to go over DMVPN. This is, of course, part of the Cisco Labs series videos that I'm creating to prepare for a test, and this will be actually the first one that's at the level of the test that I'm taking. And the goal for me is to get to the point where I can perform this task that we're about to go over, like as if it's the back of my hand. It's, you know, for these tests, you only have a couple minutes per task, and you know, if you don't work on it over and over again, there's no way you're going to have the time to, you know, do other questions on the test. So again, today's video is on DMVPN, and of course, well, first let's go over the video. And you can see we have 3 routers, and we're going to make this router 1 is going to be the hub, and then router 2 and router 3 are going to be the spokes. And you see the loopback addresses are 111.222.333. The DMVPN network, when we are done, is going to be in the 10.11.x network, but for now, when the lab is created, it's going to be automatically configured for the following IP addresses: 201.1. and then the router number. So .1 for router 1, .2 for router 2, and .3 for router 3. And you see I'm doing that not just for the final IP address, but also for the second or the third octet, if you will. So the third and the fourth octets are specific to the router. So let's start off by setting up the lab using the script that I went over in the previous video, but I'll spend a little time and show you guys this one as well. As you can see, I have the router 1 going to a switch, and then the 2 other routers, so the hub and then the 2 spokes. And then I pre-configure the IP address of the loopback address as well as the physical interface, and set up a static route so each router can communicate with the interface IP address. The rest of it's going to be up to you as part of this lab. We will not have any host systems. This is just for DMVPN, so very simple. We'll go ahead and run this, and it'll set up the lab for us. Now that it's done, go ahead and start it. And let's get back to the video and the Word document. Most likely router 1 is going to come up first, but until it's up, we can of course look at the interfaces. It will match the script, but there's no reason to look at the script, right? Because all the information is here on CML. More viral depending on which version you have, but I'm pretty sure because it's cloud-based, I'm pretty sure you're going to be using CML. Well, actually, I can't say that. It could be CML, it could be viral, I don't know. Anyway, here you go. Router 1 is connected to switch 1 on gig 00 for both. Router 2, 00 is going to 01 on the switch, and router number 3, 00 is going to 02 on the switch. And you won't have to do anything on the switch because, as I stated before, by default VLAN 1 is configured on every single port. It is insecure. It is only for lab. But what that means is, of course, looking at this diagram, these 3 different networks are being shared on the same VLAN. Normally, you would have different VLANs for each network, but for this particular case, we're just kind of emulating like you're out on the internet. So let's go ahead and see if anything is even close to being up yet. Okay, so router 1 is up. And the first thing we need to do is, well, let's make sure all of them are up. So all of them are up. Let's make sure the switch is. Okay, good. So we'll start on router 1 because that's the hub. And we'll configure the hub. Obviously the interface and loopback is already set up. So the only thing we need to do is make sure that we have connectivity. And if we have connectivity, we don't need to troubleshoot that. And good. Everything is looking good. So our first step is to keep things simple. You start out with GRE because you don't want to add encryption and everything else until you know 100% that the GRE tunnel is up and running, configured the way you want, and you have EIGRP working the way you want as well. And once you have all that established, then you would protect the tunnels. There's too many times where a location is not configured correctly, and really the encryption ended up having people spend days or even weeks or months troubleshooting the encryption part just to find out in the end it might have been connectivity, or it might have been packet loss, or it might have been EIGRP misconfigured or not fully configured, stuff like that. So always start off with the GRE, make sure that it works before adding EIGRP, and then adding, of course, the IPsec. So we'll do it in those steps to keep everything simple and make sure that everything works. So the first one is to connect the is to communicate, or to create the tunnel that will be used to communicate between the different routers. We are setting up the hub, so we'll set that up. Now, if you remember right, over here, the DMVPN network is 10.1.1.x. Here, the very last octet is going to be the router. So we'll set up all three routers with this information. This is the same whether it's a hub or a spoke, so that's what we're doing right now. And in your situation, in the real world, the source interface might be different. This is only specifically for the lab. And the network ID will just be the router done 3 times. So that'll really make it simple when we're trying to figure things out. Now here, because this is the hub, we're going to set this up for multicast dynamic. And when we get to EIGRP, we'll have something similar to configure for the 2 spoke routers. But right now, we're just going to do this for the hub. So we'll create the map, and it's going to be dynamic. Let's go ahead and configure the first spoke, and it's going to be exactly the same thing. As you can see, it's not there right now, right? Tunnel 1, 2, 3. So let's go ahead and configure it. This is router 2, class C. You see right here for the spoke, for the spoke, it's not going to be, the mapping is not going to be dynamic. So we're going to say, hey, you know what, 10.1.1.1, which is the tunnel IP address of router 1, is basically the source of truth for the next hop routing. And then we're going to map which interface IP address to which tunnel IP address of the hub router. So, source of truth, basically, and then how do we map that IP address? What is the actual interface IP address? So, and we are mapping void. And you should see the tunnel come up. But, well, we'll worry about that in a second. Oh, there, it did go up. Before we even set up the network ID. Tunnel 1, 2, 3. Class C. Typos are always a problem. Address correctly, should be good. Okay, let's go ahead and go to router 1 and we'll do some verifications. So we'll see the details of the next hop routing protocol. You can see that there's two tunnels. You have spoke 1 or router 2, if you will, and router 3. You can see the tunnel IP address and the interface IP address. So if you always wondered, well, how do I find that information? You just type in this command. Help you debug any situation you run into, and it's usually going to be connectivity at this point because we're only doing GRE, we're not doing IPsec. At some point, if we do add IPsec, well, different story. And then if you do show DMVPN detail, you're going to see more details about the two tunnels that you have. If you look at the mapping, you remember we mapped it dynamically, so you can see the attribute here. So what does that mean? Well, unlike IPsec site to site, you would have to have a configuration for every single, it's statically configured, right? With DMVPN, it's going to be dynamic, and we'll also cover that when we do Flex VPN as well. Because the best use of it is dynamic, where you only have the hub with one set of configuration and then the spokes with another set of configuration, and you don't have to configure the hub with every single spoke configuration, which is an administrative nightmare, and it opens up doors for problems later on. Let's go ahead and make sure we can ping the two tunnel IP addresses, which as you can see we do there. So we're good. Now let's set up the EIGRP. As you can see, look over here and you'll notice that we don't have dynamic routing set up at all. And that's our goal right now. So we'll set up EIGRP 100, and we want to use the loopback address and the tunnel IP address. So, and that could be, I mean, it doesn't have to actually be that. It could be whatever is needed, but you are going to want to have the tunnel IP address at the minimum. But our goal is to have the loopback and the tunnel IP address. And if you notice, I'm specifying the exact IP address of what I want included in the EIGRP. Some people do a full network. you have less control over explicitly defining what you want in this advertisement. Now, another topic here that's part of DMVPN, but it's the tunnel configuration, and it affects EIGRP. So with EIGRP and you're the hub, you want to be able to receive EIGRP information from a hub and send out that advertisements to another spoke. So that way this spoke knows about this spoke's segments, network segments. By default, that's going to be blocked because it's the same interface, tunnel 1, 2, 3. So we're going to have to change that behavior specifically for this tunnel IP address. And then the other thing is there's two ways we could do. We could either leave this as the hub, advertising itself as the next hop for the various spokes, or we can say, hey, once we've established, you can learn how to go direct to the other spoke. In our case, that's really what I want to do. So in order to do that, I need to say, change the behavior again of EIGRP and say, when I'm doing EIGRP out of this particular tunnel interface, I don't want to advertise myself as the next hop, even though I'm learning from spoke 1 and sending out to spoke 2. I want to let spoke 1's advertisement stay the way it is and not change it. Normally it would change it, so then you would become the next hop for whatever. But that really is only useful in a non-DMVP configuration, and you have multiple interfaces. And a lot of times, these two things are a cause of problems when you're troubleshooting multiple branches with multiple routes, and you have 4G, and you have, RNS or MPLS, and what have you. And you forget. Some people forget that when you receive an advertisement on this interface, it's not going to advertise it back out that interface. So if you have multiple IPsec, if you have multiple connections, in this case DMVPN, that can cause problems with the routes. If the whole point was to allow that route to go through it. If it's not, you're pretty good. You might as well keep it so you don't advertise the additional routes. It's completely up to whatever your implementation is. That's the wonderful thing about these type of devices. You have full control. So this is the hub, and we're done with the hub. Let's go ahead and configure this one. So again, EIGRP. We want to advertise the loopback and the tunnel IP addresses. So we'll go loopback, and then the tunnel IP address. So these two right here. So let's go ahead and map multicast, because EIGRP is a multicast protocol. We don't have any kind of multicast mapping set up for this, and I'll show that. So we're mapping for the next hop network information, but we're not mapping multicast. And multicast will not be sent through this tunnel if we don't map it. So let's go ahead and map that out. And here it's going to be not the tunnel IP address. It's going to be the interface IP address, and that's where where this map really comes in, right? So now EIGRP should be up for this. Now let's go ahead and look at that. I may have missed a step. Find out. spoke here again. Router configuration not there at the moment. Let's fix that. We'll advertise the loopback. And this time, we'll correctly specify the tunnel IP address. The neighbor should come up in a second. I just need to configure the multicast. For everything to be correct. So now, as you can see, the best test seems to be from router 2. So if we look at the route table, and we only want to look at the EIGRP, we're on router 2, so the advertising of 111 and 333 is what we're looking for, and you can see it there. And we can ping. Okay, now that we know that that's working, let's go ahead and configure encryption. So now we're going to protect the tunnel. So the GRE is working fine. We tested everything. We were able to look at the VPN. We were able to add EIGRP. We tested it. Now let's encrypt it and make sure that once it's encrypted, that we can still do everything that we could before. And it really helps to do things in these type of steps, because you want to troubleshoot and focus on the various levels instead of trying to do it all at once, or else it'll take forever. So we'll set up the IPsec policy, and it's going to be 10, and we're doing MD5 hash for now, and authentication is going to be pre-share key, and we're using group 2. I know that that is old, and same with triple des. I mean, well, triple des is still good, but group 2, we'll use that. Because remember, this is configuration. This is all this is. The encryption methods, there's better methods, but it's just changing this policy, or maybe adding additional policies so you can do whatever encryption requirements your company has. We did pre-share keys, so let's go ahead and specify, of course, Cisco. Like I said before, Cisco is what we're going to use for all the labs. And now that we're done setting up the ICE account configuration, we want to set up the IPsec. And with the IPsec part, really all we need to do is set up the transform set and then point the profile to the transform set. So let's go ahead and do that, and we'll call it tset, and we'll do des and MD5, and then we'll make it a transport. Did I type that right? And now that we've created the transform set, let's go ahead and create the profile. And the profile is going to point to the transform set we just did, and now we can protect it. So we've done everything we need to be able to protect this tunnel. We can encrypt it, we can set the protection. We're going to use IPsec profile TST. Okay, now it should drop any tunnels I have right now. And here, this particular message, whenever you see this, that really helps tell you the story, right? When you're troubleshooting and you're protecting the tunnels, if you see this message, you know that one of these guys, and here it tells you which one that it's telling you about right now. One of them is not using encryption. It's not protecting the tunnel. It's trying to establish a non-encrypted tunnel. So if you are using encryption and you see this, luckily this message tells you exactly which one is not following the rules. So let's go ahead and set up the rules for the two spokes. So we'll set up the policy, and we're doing #5. Authentication is pre-share. Oh, #MD5. Authentication is pre-share. The group 2 is what we're going to be using for this. If I can spell it right. That's what I get for not looking at my fingers while I type. And then we'll use triple des for the encryption. Let's go ahead and set up the when you do address 000, that means any address. If you want to have more secure, you can specify the exact IP address. But for, I think, most tests and for our type of labs, it's just faster to set up one password for all attempts, and it makes it a lot easier to troubleshoot and what have you.
Playing from desktop 06 SHFU4.
So, where was I? Anyway, let's create the transform set. Transport mode. And then create the profile. Protection, IPsec, profile, yes. And now tunnel for spoke 1 or router 2 is up. So encryption is up and running exactly the way you want. Let's go ahead and bring this one up now. So create the policy. Pre-shared authentication. Group 2 in this case, encryption is triple des. And here we'll set up the key. And now set up the transform set. Profile. Profile is test. Set transform set. Set. And then protect the tunnel. And the tunnel should be up. So let's go ahead and follow these tests to validate, and then we're done with this lab. So we'll go here, router 1, crypto, sec, and if I can spell that right. And we want to look at the SA. see that packets are being encrypted and encrypted, which is exactly what we want to see. There's plenty of IPsec policies now live. Let's go ahead and look at the IPsec. You can see that all the tunnels are up and idle, which is good. And let's ping 333 using, I can type things correctly, using loopback 0. Oh, 333, not 334. And there you go. We can, of course, there's some really useful parameters when looking at the IPsec SA, and this will really help you focus on what you're looking for. So if you look at packets, it'll let you see the encrypted and decrypted packets, encapsulated, right? The number of packets, encrypted, decrypted. Now this basically, if you do this command right here with this filter, it really allows you to focus on what you need to troubleshoot for it and see if there's something with the encryption. However, if you control all routers for this VPN connection, just take a look at the configuration. It's really going to make a big difference. There you go. Well, I hope you enjoyed this lab. Give me a thumbs up if you like it. Thumbs down if you don't. Comment if you want to suggest something that you want to see more of, if there's something that could change, improve on this. Again, all my scripts are in the GitHub, the PTC or Pacific Tech Center GitHub that I have, and it's in the description on how to get to it as well. So mahalo for watching, and aloha.